morning. So I hope all of you can hear my voice. Okay, I need to start this class earlier because by 11:30 I got another meeting with my colleague. Okay, so we will begin this class a little bit early. I hope you can see this whiteboard with the electric circuit. So today we are going to continue our lecture, okay, regarding on circuit analysis. Okay, today all of you will learn about how to use nodal analysis, okay, in order to determine the voltage value. Okay. Okay, before I proceed with this topic, okay, I want to remind you that your midterm exam will be next week on Wednesday, 25 of term, okay, 25 of November 2020. So this is basically on our class, okay, which is scheduled on Wednesday. Okay. The time is from 10 a.m. until 12 p.m. I hope all of you prepare. Okay? And then the platform for this exam will be using Kalam. Okay? The platform will be Kalam. Okay? And then I need you to prepare all of the software and hardware. Okay, in terms of software, you must make sure you have download all the apps in order to convert uh, your your uh, your your method, your calculation from your paper until converted to PDF. Okay, so here is PDF converter. Okay, and then hardware is your pencil, your piece of paper, okay, all of that stuff lah. Okay, and then you need to submit your midterm exam, okay, in the Kalam. It's just like you submit your assignment as well as your lab report. It's, okay. And just for reminder, okay, after the exam, okay, which is after the 2 hours, okay, I will give you another 15 minutes just for you to upload all of your stuff. Okay, I hope it is clear, or I hope this instruction is clear. Okay. Okay. Any submission after this 15 minutes, I will not accept. Okay. But if you have a very strong reason, which is I can consider, then I will accept your submission. Okay. Without further ado, I will begin my lecture, okay, regarding on this nodal analysis. So nodal analysis is another method for you to determine the voltage. The difference between nodal analysis and the voltage and the mesh analysis or loop analysis is that you need to assume the node at which the circuit element is connected. So for mesh, of course, you need to analysis in terms of the loop of the circuit. Okay. And then for nodal analysis, you need to analysis based on the node. Okay, assumption of the node. Okay, if you have this kind of circuit, okay, first you need to determine the ground or the reference node. So in this case, this is the reference node. Okay. First, assume the reference node. Okay, and then the second part is to denote the node. Okay, so if you remember, the definition of node is a point where there are two or more than two elements connected together at the node. So in this case, we have this node, which is I name it as V1, and then this is considered as node V2. Then this is considered the node at V3. Okay. This question need you to determine the voltage at V. Okay. Okay, this is the question. Then, okay, um, this is the first instruction, and then the second instruction is to assume the node. So in this case, V1, V2, and V3 is the point of the node. Then the third instruction is to apply Kirchhoff current law okay, at each node. Okay. Okay, in this case, I will apply KCL at V1, V2, and V3. Okay. At node V1, okay, there will be three ways of current flow. Okay. And then at V2, there will be three ways of current flow, and then as well as V3. Okay. Now I will start the calculation. Okay. At node V1, okay, you will see, okay, the current flowing outside of the node. Okay. However, there is also current flowing from the I1, which is provided from the current source I1. So you can write it as I1, okay, I1, okay, okay, since the current I1 is opposite direction to our assumption, so I will write it as the negative I1. Okay, and then current flowing downward, okay, which is we will write it as a plus V1 minus with V at the ground or V output, V ground, V VO, V naught divided by 500 ohm. Then this is because as the current flowing through the resistor, there will be a potential difference in terms of its voltage. So that's why you need to minus with the V naught at the ground. So the voltage difference here will be represented as V1 minus with V naught. Okay. Also, you can relate the current I, which is equal to V over R. Okay, going to the third current flow, which is at V1 to V2. Okay, so current flowing at V1 and V2, you will have V1 minus with V2 divided with 500. Okay, then remember the current is equal to the summation of all the current equal to 0. Okay. Okay, now we go to the node V2. Okay. At node V2, okay, you will have V2 minus V1 divided with 500 ohm. Okay, then plus with V2 minus with V naught or V reference divided by 1000 ohm, and then V2 minus with V3 divided with 500, okay, equal to 0. Okay. Now we have a node at V2, and then we go to the node at V3. Okay. Here, node V3, you have current going to the left, downward, and to the right. So you can write it as V3 minus V2 divided by 500, then plus with a V3 minus with V going to the ground or to the reference node divided with 500, then plus with, since the current I2 is opposite direction to our assumption, so you will have a negative I2. Okay, I write it as a big I, then equal to 0. Now what you need to do is to arrange the equation. Now we go back to V1. Here I will arrange. Okay, since V node or V reference is to the ground, so basically V node is equal to 0. Here I will write it as V1 over 500 plus with Okay, so this will be our first equation. And then going to the node V2. Okay, node V2, I will write it like this. Yeah, I will bring this to the left, so you will get a negative V2 divided by 1000. Okay, here V2 minus V1 plus V2 minus V3. Okay, okay, this will be V2 minus V3 equal to 0. Okay, now we go to the third equation. In this equation, okay, V3 over 500 plus with V3 over 500 equal to I2. Okay, then negative V2 plus 2V3 divided by 500 equal to I2. Okay, bring this to the right hand side. Then negative V2 plus with 2V3 equal to 500 I2. Okay. Okay. So now we need to determine the voltage at this part. Here V at this side is represent as a V2. So what we need to do is to substitute V1, okay, in terms of with respect to V2 and I1. So here you will get negative 500 I1 plus with V2. Okay. Then V1 is equal to negative 500 I1 plus V2 divided with 2. Then okay, this is for V1. Now we go into the V3. Okay, V3. So here 2V3 equal to 500 I2 plus with V2. V3 is equal to 500 I2 plus the V2 divided with 2. So substitute V3, okay, with the V3 from node 3. Okay, here you will have a negative 500 I1 plus V2 divided with 2 plus with 2 1 over 2 V2 minus with V3 500 I2 plus with V2 over 2 equal to 0. Okay. So now you have uh, all of the voltage in terms of V2 and I1 and I2. Okay. So here, if you change it to uh, it will be 5 over 2. So, but before that, we expand the equation. So you will have a 500 I1 minus V2 over 2 plus V 5 over 2 minus 500 I2 minus V2 over 2 equal to 0. Now you realize all of this is divided by 2. Okay, so you can write it as 500 I1 minus V2 plus 5 minus 500 I2 minus V2 equal to 0. Okay, bring 2 to the right hand side. So you will have 500 I1, okay, minus 500 I2 minus, okay, this is V2, okay, minus with 2V2 plus 5V2 equal to 0. So here, you will have 500 I1 minus 500 I2 plus with 3V2 equal to 0. Okay, then V2 is basically represent V. So rewrite the equation. So the voltage V will be equal to minus 500 I1 plus V 500 I2 divided by 3. So basically you will have a 500 1 Okay, 500 divided by 3, 166.7 minus I1 plus with 166.7 I2. Okay. 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 That is the answer. Okay. I hope you can understand that this part. I will go to the second example. Okay. Second example. I hope you get the concept of the nodal analysis. Now I want you to solve this simple example. Determine using nodal analysis determine voltage V1 and V. Okay, try to do on your own based on the instruction that I give you previously. You can ask me, no problem. Okay. So I will write it as first at node. Okay, this is will be the reference or ground node. So Okay, at node V1, you have a current flowing opposite direction to our assumption. So you will have a negative 4 milliampere, and then plus with a V1 minus with V naught, which is V ground, divided by 6K, then plus with V1 minus with V2 divided with 12K, okay, equal to 0. Then the second part will be at node V2. Okay, V2 minus with V1 divided with 12K, then plus with V2 minus with V going to the ground equal divided with 6K, then plus with 2 milliampere equal to 0. Okay, you rearrange the equation. Okay, this side I will time with 2. So here you will get a negative 48. Now this will be our first equation. Then this will be okay. Okay, bring the 12 key to the right hand side. So rearrange the equation. You will produce this equation. So you will have a negative 24. This will be the second equation. So using
Sir,
here
dekat V2 tu bukannya 3V2 ke?
V2 mana
Yang last kali tu, yang negative V1 tambahkan 3V2 ke?
Oh 3V2 Okay 3V2 sebab dia 2V2 okay 3V2 3V2 Okay. So using simultaneous equation, so you press your calculator, okay, at mode 3 times, then press the EQN, and then select two unknown. Okay, the first unknown will be A1, which is 3. Then B1 will be -1. Then C1 will be -48. And then A2 will be -1 plus with 3. And then minus 24. So for V1, you will have a value of a 21 volt. Then V2 is equal to -15 volt. Okay. This is,
Sir, ada soalan.
yeah.
Yang at not V1 tu,
Okay.
kenapa negatif 48?
-48. Oh,
Yang bukan positif ke?
positif Okay, saya tertekan saya rasa. Okay. So this will be positive -4 milli bring to the right hand side Okay. So this will be a positive. Okay. So padam balik Okay, again press your calculator. Select two unknown. The first unknown is 3, -1, 48, -1, 3, and -24. So V1 equal to 15 volt, V2 equal to -3 volt. Okay. 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 Did you have any question? Okay, I will go to the next example. Okay. Now, this question is this arrangement of circuit is little bit different. Okay, because you basically you have a voltage, okay, at 12 volt. Okay, at this part. Okay, if you have in comparison with the mesh analysis, if you have a current source, okay, in between two loop, so you will have a super mesh. Okay, on the other side, if you have a voltage, okay, in between two node, okay, then this will be a super node. Okay, So if you have a super node, you no need to you will have a equation that consists of V2 and V3 in one equation. Okay. 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 I will write this equation. Okay. This at node okay, this will be the first node, which is node V2 and node V3. Okay. You will combine both of these equation at node V2 and V3 in one equation. Okay. So at super node, okay, you will have an equation of V2 minus with 6 divided with 2k plus with a V2 divided with 1k and then plus with V2 minus with V3 divided with okay, V2 minus sorry okay, you will have equation of ignore the 12 volt and then you write it as V3 over 2k okay, plus with V3 minus with okay, minus then minus 4 volt divided with 2k equal to 0. Okay. Then at super node, okay, you will write your another equation, okay, consists of V2 minus with V3 equal to negative 12. Or you also can write, okay, okay this is up to you, depending on your assumption. V3 okay, minus V2 equal to 12. Okay. Okay. But remember, if you take the V2 minus V3, which is on the opposite direction of the our assumption, make sure you include the negative. And then for the, if you take the current flow from V3 to V2, so V3 minus with V2 equal to 12 volt, which is the polarity is the positive. Okay. Now you solve this equation. Okay. The question need you to calculate the current at I naught, okay, which is V3 over 2K. Okay. Now you need to determine the voltage at V3 first. Okay. So 1K you will times with 2. Okay. Now I bring 2K to the right hand side. Okay, so it will be 0. Okay, now you have an equation consists of V2 and V3. Okay, since we need to determine V3, so we can arrange the equation here as with respect to V2. So substitute this to this equation. Okay, negative 12 plus V3. So negative 36 plus with 3V3 plus with 2V3 go to negative 2. So this will be 34. Okay. So V3, 34 divided by 5. So you will have a 6.8 volt. Okay, so now use nodal analysis to find I naught. So I naught is basically V3 over with 2K. Okay, so 2K.
So why is negative 2?
Negative 2.
Why is negative 2?
Okay, 3V2. Okay, this one will be positive. Positive. Because negative 6 plus with 4. So when you bring to the right hand side, you will be 2. Okay, plus with 2. Okay, I will write it from the beginning. Okay, 3V2 V2 negative 12 plus V3 negative 36. Okay, you will have a 4v3, 5v3 equal to 38. If v3 is basically 38 divided with 5. So 38, you will have a 7.6 book. Okay? So substitute this value into this equation. So you will have a 3.8 milliampere. Okay, so this will be the third example. Okay. Do you have any question?
No.
Orang sama je yang menyaut.
No, sir.
Pan ada pan. Pan. Puvin. Are you there, Puvin? Ya, bagi saya save attendance dulu. Okay. So now I will give you one example and I want you to try to solve it in a 15 minutes time. Okay. I'm not sure this question need you to solve what value. Um, okay. Anyway, try to write the equation representing V1, V2, and V3. Ada any question? Okay. Okay. Attendance sangat memuaskan. Saya harap semua faham lah apa yang saya ajar. Okay, bagi saya elektrik and elektronik ni subjek yang sangat penting sebab apa, dalam dunia sekarang ni segala-galanya adalah dah bukannya melibatkan conventional mechanical semata-mata. Jadi kalau kita tengok aplikasi handphone, aplikasi laptop, sebenarnya banyaklah komponen-komponen elektronik dan elektrik dalam tu. Okay. Contohnya macam transistor, kemudian kalau yang besar sikit kita ada elektrik motor, and then resistor, okay, LED. Dan benda-benda ni sebenarnya adalah kalau orang future is electronic. So even kalau kita tengok automotive industry, depa pun dah ke arah electric vehicle. Okay. And then okay. So this subject is very important for all of you. Okay. Okay.
Asal,
Ya.
yang untuk 2IX tu macam mana buat persamaan dia?
Okay. Bagus siapa yang tanya ni boleh saya tahu nama?
Sarah.
Sarah, okey. Bagus maksudnya Sarah alert. Okay, untuk 2IX ni kalau kita tengok current flow ada pada R3. Jadi pada R3 ni kita boleh tulis equation mengikut flow IX. Okay, so basically IX is equal to V3 minus with V2 divided by R3. Okay. Okay. Jadi saya masa sekejap saya ada urusan sikit. Okay, ada apa-apa soalan ke? Saya akan tunjuk equation dia. Okay, so basically you will get these three equations. Okay. And then you will also have another one equation which is represent Ix. Okay, satu lagi topik yang sebenarnya saya rasa sangat penting for you to study, topik programming. So programming and then electronics, dia bergerak parallel. Okay. So kenapa kita perlukan programming dalam elektronik? Salah satu dia punya reason dia adalah untuk membuatkan elektronik tu lebih efisien dari segi penjimatan kuasa. Okay. Jadi saya minta sangat pelajar-pelajar saya untuk gunakan masa sepanjang diploma ini untuk tingkatkan knowledge dari segi programming. Okay. And then in fact simulation multi-sim tu pun adalah satu platform yang sangat baik lah untuk kamu mengasah knowledge mengenai elektrik and elektronik. Okay. Okay, so basically semua dapat ke?
So equation yang tu macam mana?
Macam mana? Yang mana?
Macam mana equation yang pertama tu boleh jadi macam tu? So, saya dapat IS je.
V1
Hmm.
yang ni Okay so basically ada, sekejap saya cuba tulis current at IS, so negative at node V1 okay. So you will have a negative IS plus with V1 minus V2 divided by R1. Then you also have another one which is plus 2Ix. Plus 2Ix equal to 0. Okay. Now, okay, kita arrange macam ni V1 minus V2 divided with R1 equal to negative. Okay, this is negative Why? Because it is in the opposite direction So this one will be a negative. Okay. So when you bring to the right hand side, you will have a 2Ix plus with Is. Okay. Dapat ni Sarah? Dapat macam ni? Dapat kan?
Okay, dah dapat. Tapi kenapa dia ambil yang situ? Kenapa dia tak? Oh, okay, baru nampak. Okay.
Okay. So untuk V2, dia akan ambil sini V2 minus V1 divided with R1. And then right hand at the right side V2 minus V3 divided by R3. Then R2 V2 minus with V0 divided by R2. Okay, untuk seminggu ni sebelum midterm saya tak akan bagi sebarang report, okay. Tapi saya akan upload beberapa assignment, okay, untuk preparation kamu midterm Okay, 3 benda je yang saya minta kamu study. first circuit and voltage divider. Second is mesh analysis, and then third one is the nodal analysis. Okay. Habis je midterm ni, lepas ni calculation dah hampir tak ada. Lepas ni semua lebih kepada teori. Okay. And then kamu perlukan teori tu untuk buat lab. Okay. Jadi lepas midterm tu kita akan teruskanlah dengan kelas-kelas lain. Okay. Buat masa ni study untuk midterm dulu. Okay. That's all class for today. We will meet again next week. Okay, but it will be a midterm exam, and then I will use a kalam, okay, 100% kalam for your midterm. Okay. So please make sure that you have the best internet connection next week. Okay. I believe you will have lots of midterm. So make sure your data, your internet, data and internet is enough for you to so that your exam will go smoothly. Okay, one more thing. Okay, saya nak ingatkan juga dari segi penipuan. Saya tak naklah sebut penipuan sebenarnya, tapi tiru. Bagi saya student tak perlu meniru untuk subjek ini. Sebab apa? Kamu boleh buka contoh-contoh yang kamu buat dalam kelas ataupun dalam assignment, and then soalan dia adalah hampir sama sebenarnya dengan assignment dan yang telah saya bagilah. Saya takkan bagi satu topik yang saya tak ajar. Okay. So as long as kamu ada nota dan soalan, tak perlu untuk kamu meniru sebenarnya. Okay, saya harap clear. Okay. Okay, that's all class for today. Saya akan upload video ni